Hi, my name is Deepa. Steph and we are presenting about the process we apply to update address location to meet NINA standard. Our presentation is charted into 4 parts. First, we'll talk about how our current existing address points were generated and what the next-gen NINA requirements are for address points placement. Second step, we'll talk about the update process we used. Then I'll go over the examples to show our results, and finally we'll talk about the next steps. So majority of our address point was generated from a join between mod4 data and statewide parcel data. What's mod4 data? It's our New Jersey tax system, which was established in 1966, which was created using COBOL for uniform preparation, maintenance, and presentation of New Jersey tax data. Since then, various fields have been added and many procedures have been implemented to create a complex data set. We used an ETL tool to combine this data with our parcel data. The property location field in this combined data was utilized to create our current address points. Initially, all our address points was placed as parcel centroids since statewide building footprints were not available. Then later we moved them to front of the parcel close to the road center line for validation process. Just on the side note, a couple counties and townships have been maintaining their own address data, so we excluded them from our process. Well, we realized we needed to provide consistency and standards for placement of our address points. NINA has various recommendations for placement of address points. Since we were using building footprints for our process, we adapted placement methodology for structure, which is placing our primary address points within the appropriate building footprints. These guidelines will help 911 for location validation, call routing, map display, vehicle routing, and emergency notifications. In the next section, Steph will talk about the process we used to update our address point to meet these NINA standards.
Okay, so as Deepa mentioned, I'm going to talk about our update process. Here's just the general overview of our process. We used Python 3.6 and the arcpy module. Since New Jersey is a pretty dense state, the process was run at the county level. The general idea was to loop through the parcels and make decisions based on individual circumstances. We would then create an output feature class with updated point geometry that contained a flag describing how the update was made. These flags can be used in the review process, and once the process is complete, a second script can be run to replace the old address points with the updated point geometries. Here's some of our reference data. We used our statewide building footprints from NJ, our address points, which, as Deepa talked about, were initially generated along road center lines based on mod4 records, and our parcel data. So first we had to do some initial analysis, and as you can see here, maybe at first it seemed pretty straightforward. You can clearly see which address point corresponds to which building footprint, but upon closer inspection you can see it's not that straightforward. So after seeing this, we decided maybe we could intersect the building footprints with the parcels and use those building footprint geometries as the appropriate building footprints to move the address points to. But that would not solve everything. Here you can see multiple buildings intersecting the parcels, so we decided maybe we can just choose the largest intersecting geometry as the appropriate building footprint. But that won't always work either. Here you can see on lot 20, there's a tiny sliver of the building that really belongs on lot 21 and 22, intersecting lot 20. So if we just use the intersecting geometry on lot 20, that would not work. So we decided maybe we can just ignore these small slivers. So after doing a little bit more research, it seemed like 250 square feet looked like a good cutoff point. This would also solve an issue we were having of things like sheds and garages being the only footprint on a parcel, and that's not the appropriate place for the address points. So the only problem is if we ignore these small sections, then as you can see here, this is showing the square footage of the intersected building. You can see on lot 11, the square footage that intersects that is 116. So then we would be losing this whole building. So we needed to figure out a way to check that this whole building wasn't intersecting with other address points, and then we know it would be safe to say to move that point to the building. If other parts of the building were intersecting address points, however, that small sliver there, that's 221 square feet, that can be ignored for lot 1. That's not the appropriate building footprint. So after our initial analysis, we knew the information we needed to know about each parcel to make an informed decision. The things we needed to know were, are there any address points on the parcel? Is there a building on the parcel? And how big is that building? So you could do this by looping through the parcels and doing some spatial analysis, but that would take way too long. So we decided to store the information in a Python dictionary, and then loop through the parcels with a search cursor and look up the information we needed from the dictionary. Python dictionary is an unordered collection of items in which each item has a key and value pair. Dictionaries are optimized to retrieve values when the key is known. So our idea was to create a dictionary where the key is a unique parcel ID. In our database, this is a PCL GUID, and the values are the information that's about what's on each parcel. So how do we go about retrieving this information? First, we run an intersect between our parcel data and our address data. You can see here in the attribute table, these are the fields that we needed to store in the dictionary. We have the PCL GUID, which is going to be our key. That's the parcel unique ID. That's a key in the dictionary, and then we are adding any address points that we found. We're adding those app GUIDs as values, and also the PAMS pin. The PAMS pin is an identifier that's created from the concatenation of the municipal code, the block, and the lot. We then ran an intersect with our parcel data and building footprints, and we added that information into the dictionary as well. So again, we have the PCL GUID, that's our key in the dictionary. We're adding the FID, the unique ID for each building, and then the shape area. And then we're also generating the point centroid of these intersecting geometries ahead of time and storing that in the dictionary so we don't have to do it within our search cursor. And then we're also storing the PAMS pin in the dictionary if we didn't already get it from an intersecting parcel with the address point. So, like I said, our resulting dictionary is set up in a way that the key is our parcel GUID, and all our values are the address points, which is a list of those unique address point IDs, the PAMS pin, and then another dictionary that is actually containing the building ID, the building shape area, and the point centroid of that building geometry. So I'm going to walk through how we handled parcels with additional lots. This is a good example of how our logic worked and how we pretty much applied this logic to all the other different scenarios in different ways. So additional lots, for those of you who don't know, are just lots that were assessed with the primary lot. So the first step when we got to any parcel was to check to see if these additional lots were populated. That's because you can't just look at the primary lot. You need to look at the additional lots and the primary lot together to make an informed decision. You also can't assume that a building on the current lot that you're looking at is the right one. As you can see in this image, you have to look at the additional lots as well. So anyone who's worked with additional lots, you'll know that parsing this field is not an easy task. You can see some sample entries down below with no standardization. So all we did was we did what we could in identifying trends where we could apply simple logic. So split by comma, split by hyphen, Those were simple ways to parse and, see and handle a lot of these records. So here we're looking at lot 6. You can see it's highlighted, and it has lots 5, 46, and 47 populated as its additional lots. So what we did in this case was we basically took these lot numbers and created a mock PAMS pin, what we assumed the PAMS pin would be by taking the municipal code, the block, and concatenating it with this lot. So we did that for each of the additional lot values. And then if you remember, the PAMS pin is a value that we stored in our dictionary. So we're going to that dictionary, seeing if these PAMS pins exist, and then we're retrieving the parcel IDs, which are the keys in our dictionary. So once we have those keys, we have all the information we need. We can then loop through this list of keys and retrieve all the information from the dictionary. So what we did basically is each of these lots, if there was an address point on the parcel, we ignored it. If there was no address point on the parcel, you then checked if there was a building on the parcel. Then we made sure that that building was larger than 250 square feet. And we kept going through each building footprint, and the largest one is chosen, and then the point is updated to the XY coordinates of that largest intersecting building geometry. So you can see here, lot 46 had the largest intersecting building geometry for this situation. So after the process was complete, we did a little bit of cleanup. Basically, we checked the entirety of the building footprint now, and if there was only one point on it, we moved that point to the center. If there were multiple points, we left them right where they are. So like I said, the output is a feature class with the updated point geometry and also a flag describing how the move was made. So you can see here on the left we have a flag that says completely within. So this is one of our flags that we have high confidence in, and really little review is needed because the building and the address, there's one address point and the building is completely within the parcel. You can see on the right we have a flag that says additional lot used. So this means the building that we used for that address point was actually an additional lot. So you might want to give that one some review. You can also see we just included some helpful reference fields in the output to assist in QC. And that AppGUID field is what can be related back to the original address point. We also have some documentation on our flags and some in-depth logging. So every time our script gets to the next parcel, it's basically logging everything that it's encountering, and then the flag that's determined is stated at the end. So if anyone has a question of why a certain point was placed where it was, they can check the logs for that. And once the review process is complete, we have a secondary script which uses a relationship between the address point IDs in the output and the original data to update the original address points to our updated location. So now I'm going to hand it back over to Deepa to go through a couple more examples of what we found.
Thanks, Steph. Now let's look at some of the examples to see how we adapted NINA standards to move our address points. All these examples are tagged based on our output flag. For consistency, blue is where the original point was and pink is where the new location is. As Steph was explaining, based on the intersect with address point and parcel data, building footprint on parcel data, we found in most cases there was only one address point and one building footprint within the parcel, which was no-brainer. We moved the address point on top of the building footprint. This had a highest confidence level. So there is always more than one building footprint within the parcel, right? There could be sheds and garages. So we picked the largest building footprint within the parcel and we flagged it as the largest building found. Sometimes the multiple buildings within the parcel were close in size, like here in lot 9 and 2. Still, the largest building was used for address point placement, though the next building is close in size, so our confidence was lower. So we flagged it differently as largest building close in size for further review. Building footprints were not always completely within the parcel. It intersected with other parcels. In that case, we dealt with intersected geometry, as Steph was explaining. So you can see the address was moved on top of the appropriate intersected geometry. If the building footprint intersected with many parcels, in this case, the address is on lot 40, but the building footprint not only intersects with 40, it intersects up to 43. In that case, if there were no other address points in the other parcels, we consider the whole entire building footprint for the address placement. So in this example, the intersected building footprint in lot 21 is smaller than 250, and majority of the building footprint falls within the adjacent parcels. In this case, if there were no other address points in the adjacent parcels, the largest building footprint within both the parcels was used and flagged as largest building footprint was less than 250 for further review. We used Q-code and property class attribute to identify condos. The address was moved on top of the intersected building footprint. Some cases the building footprint didn't align properly with the parcel data, as you can see here in the left hand corner. Based on the Q code, we knew it was a condo but flagged it for further review. We considered additional lot fields in placement of address points. In this example, parcel 43, additional lot is populated, which is 42, but there were no other building footprints in the additional lot. So only the current lot was used, and we flagged it as additional lots populated, but current lot was used. If additional lots were populated by comma, we were able to parse it. In this example, even though address was in 10 and there were no building footprints, we used the additional lots to find the building footprint and to move the address points. If they were separated by a hyphen, we were able to parse it then too. In this example, the additional lot is 107 to 109, and we were able to move the address points from 106 to appropriate building footprints. In this example, for lot 9, the additional lot is 10. Even though the building footprint intersects with other geometry, we only used additional lot field. For all these examples, we flagged it as additional lot populated and additional lot used. Sometimes there were parcels with multiple address points, and there was also a ring of address points that was created to symbolize address range associated with the parcels, like commercial building. We flagged them for further review. Also, there were parcels with address points and no building footprints. In this example, you see in lot 18 and 19, and also no additional lots were populated. These were also flagged for further review. So these were some of the examples to show how our update process moved the address points to new location to meet NENA standards. Now let's talk about our next steps. This was our first step to have a standardized method for address placement and also make progress to comply our address data with NENA standards. We're also planning to update our process to improve handling of additional lot information. We're currently in the process of reaching out to counties and townships to establish partnership, so we can use their local expertise and knowledge in reviewing address points that were flagged for further analysis. A RFP has also been issued. We are hiring a contractor to generate missing address points such as apartments, shopping centers, office buildings, etc. Now we have enhanced our address data, we are also getting better geocoding results. Finally, we would like to end our presentation with an interesting illustration. If you have any questions or comments, please don't hesitate to contact us. Thank you. Have a good day.